Hello students. In this video we will be talking about matrices. That is one of the important uh, discrete structure that is used in computer science. So that's the last topic in this chapter, chapter number 2 in your textbook. That is discrete mathematics, discrete structures and its application by okay. So this is the last topic, and that is the matrices. So what we are going to learn in this video, we'll see the definition of a matrix. We'll talk about matrix arithmetics. We'll talk about transpose and power of arithmetic. And finally, we'll talk about 0-1 matrix, that are really used in Boolean algebra and computational theory, right? So what is a matrix basically? A matrices are useful discrete structures that can be used in many ways. For example, they are used to describe certain type of functions known as the linear transformations that we use it. We will use these matrices in order to represent the graphs, and those graphs in order to show the connected edges of the graphs, in order to show the directions of the digraphs. And for those graphs, we use the matrices to build the transportation systems, the communication and the computer networks, right? So many of the algorithms that are based on matrices model will be presented later in coming chapters and the coming videos. So here in this video we cover the aspect of matrix arithmetic that will be needed later, right? So we will talk about the algorithms in the of the matrices in the coming videos, but here we'll see the basics of those matrices. So what is a matrix basically? Matrix is a rectangular array of numbers. So a matrix with m rows and n column is called an m cross n matrix. So we are familiar with the matrices. So matrix is nothing but a rectangular array like this, right? Rectangular array like this, right? That has some rows and columns. So here we have 3 rows, 1, 2, and 3 rows, and 2 columns, 1 and 2 columns. So that is called the order of the matrix. So that is, in general, we call it m cross n matrix. So m represent the number of rows, this is the rows, and n represent the number of columns. So the plural of matrix is matrices. A matrix with the same number of rows and column is called, okay, the matrix with the same number of rows as the column is called a square matrix. That means if in a matrix we have the same rows and the same columns, same number of rows and number of columns, we call it a square matrix, right? For example, 2 by 2 matrix, 3 by 3 matrix, 4 by 4 matrix. So these all are the square matrices. So two matrices are equal if they have the same number of rows and the same number of columns, and the corresponding entries in each position are equal. That means we call a two matrices equal, A equal to B, when they have the same number of rows, same number of columns, and at every position the same value. Then only we will call that two matrices are equal, right? So here are some notations. Let m and n be positive integers, right? And let a11, a12 up to a1n. What does that mean? This 1 1, the first number, this is 1 1. So the first one represents the number of column, right? So this is the first number of rows. This is the first row. So 1 1. The second one shows the number of column. So the first row and first column. 1 2, first row, second column. 1 3, first row, third column. 1 n, row is still first but nth column, right? Similarly, 2 1, second row, first column. 2 2, second row, second column. 2 3, second row, third column. Up to 2 n, second row, second column. Now let's see, keep on doing that. am1, that means mth row with first column. am2, mth row in second column. amn, mth row in nth column. So that's how we represent the matrices in a general way. We use these indices 1 m and n, 1 2 3 4 5 6 up to m and n, where m represent the number of rows and n represents the number of column. So the ith row of A that is a matrix, is 1 cross n. That means the ith row, whatever is the I value, right? So this will return only one row with n number of columns, right? So one I, for say for example, this is the seventh row, so 7 1 7 2 7 3 7 4 up to 7n. So this will return one row with n columns, right? So the jth column of A is then m cross 1 matrix. That means if we are talking about the jth column, any of the column, so that represent m cross 1. So that means A1j. What does that mean? 1 is the number of row, j is the column, right? A2j, A3j, A4j up to AMJ, mth row, jth column. So for example, if m is 7, so this would be A17. That means first row, seventh column. So this element belongs to the first row and the seventh column, A27. Second element, the element in the second row and the seventh column, up to so on. M7 means element present at this position is mth row with seventh column if j value is 7, right? So this is how we represent the column sum notations. So the I comma jth element of entry of A is the element Aij. That's what I said. So at the ith comma jth element, right? So for example, for this one, ith comma jth element, this one is basically 2 comma 2. Y value is also 2, j value is also 2. Is the element in that particular, that is Aij. So how we represent it, A22, right? We can use A equal to Aij to denote the matrix with its I comma jth element equal to Aij. So that's how we can represent the whole matrix with I comma with the Aij. That's the location of that particular element. So we'll see definitely some of the examples in order to understand that. So matrix arithmetic. Now let's now as we have some the metric contains some values, right? So those values may be the integer values, those values may be some decimal values, whatever the values are. So we, if the values are the numeric values, we can definitely do the arithmetic with the matrices like we do it within integers, right? Or with the decimal values. So how about the addition? How we can add two matrices? Okay, so let A is equal to Aij and B is equal to Bij. So these are two matrices, Bm cross n matrices, right? The sum of A and B denoted by A plus B, we represent it with A plus B like we simply represent the arithmetic addition of two numbers. And the result is the M cross n matrix, right? So remember, this is these two are the M cross n matrices of the same order, same sizes, right? So the resultant would also be this of the same size, M cross n matrix. And how we obtain the values? So what we do, we add the same positions, the element of the same positions in two different matrices. For example, in the matrix Aij will be added with Bij. So element at Aij position will be added with the element at Bij position, as it's I plus I comma jth element in order. In other words, A plus J is equal to A plus B is equal to Aij plus Bij. So now let's see this example, then we will understand. So this position is A11, right? This position is A12, this position is A13. So this position is A21, this position is A22, this position is the element position is A23, and this the position is A31, A32, and this is A33, and similarly here, right? So what will happen? This is so for example, this matrix is matrix A, this matrix is matrix B. So the position in this one will be B11, B12, B13, and this would be B21, B22, B23, and this would be B31, B32, and B33. So what's the definition says? Add the corresponding elements. So A11 will be added with B11. So 1 plus 3, that is 4. So this is the resultant matrix A plus B, right? So Then A12 will be added with B12. So 0 plus 4 is 4, right? A13, that is -1, will be added with B13, that is -1. So -1 is -2, right? So similarly, A21 will be added with B21, right? B21. So that is what? 2 plus 1, that is 3. Then 2 minus 3 is -1. -3 plus 0 is -3. 3 plus -1 is 2. 4 plus 1 equal 5. 0 plus 2 equal to 2. So this is how we add two different matrices, right? Note that this is important. Matrices of different sizes cannot be added. This is important. If you have different matrices, for example, this matrix is 3 cross 3, and the size of this matrix is 3 by 3, and the size of this matrix is 3 by 2, you cannot add them. And the reason is very obvious. How you will add these three elements into the when you do not have the elements in corresponding elements in an other matrix. All right. Now let's see how we can perform the multiplication, matrix multiplication. So let A be an M cross K matrix and B be K cross N matrix, right? So the important thing is the order of matrix A is M cross A and the order of matrix B is K cross N. So that means the number of columns of the first matrix should be equivalent to the number of rows of the second matrix. Then only we can add these two matrices. Otherwise, we cannot add them, right? So, and the resultant would be M cross N matrix. So the product of A and B denoted by AB is the M cross N matrix that has its I comma jth element equal to the sum of the products of the corresponding elements from the ith row of A and the jth column of B. What does that mean? I will explain it with one example. So in other words, if AB is equal to Cij, then this Cij is equal to A1 AI1 plus B1j. That means the first element, right, of the matrix A, the second element of the matrix B, they will be multiplied plus the second element, right? So this we will see with an example from here. So here you can see one matrix. Then I will come back to this definition again. Here you can see these two matrices. So this matrix is, let's say this matrix is matrix A and this matrix is matrix B. So when we can multiply two matrices, when we can see, okay, so what is the order of the size of this matrix? So the size of this matrix is 1, 2, 3, 4, 4 cross 4 by 3. So this matrix is 4 by 3, right? And what is the size of this matrix? That is 1, 2, 3, 3 by 2, right? So we can only multiply two matrices when they have the same, okay, the first matrix has the same number of columns as the number of rows of the second matrix. Then only we can multiply. So they are fulfilling the condition, so we can multiply them. But how we can multiply? See, the first element here in matrix A, that is 1, will be multiplied with the first element. I mean, this A11 will be multiplied with B11. So that is what? 1 into 2, right? And then we will plus. How? The second element, that is A12, will be multiplied by B21. That is this one, right? So 0 multiplied by 1. That is 0 multiplied by 1 plus third element, that is B13, will be multiplied by B31. That is this one. So 4 is multiplied by 3. Come on, this pen. But anyways, so this is 2 into 2. 2 into 1 is 2 plus 1 into 0 is 0 plus 4 into 3 is 12. So that is 12 plus 0 plus 2, that is 14. So how we obtain this 14 is this formula, right? That's why this says AI1 B1J. So plus AI2 B2J. Now you understand this one, plus BI3 plus AI3 plus B3J. So on AIK into BKJ. Right? So that's how we have obtained it. So see how we obtained the second element, this one. right? So second element is, now we obtained this one. What we did, we multiplied the first row with the first column. Now we will multiply the first row with the second column to obtain the second element. So let's multiply. 1 into 2 is 2. Oh, sorry. 1 into 4, second row, second column. 1 into 4 is 4. 0 into 1 is 0. 4 into 0 is 0. So that means 4 plus 0 plus 0. So the answer is 4. All right. Now, next, the second row will be multiplied with the first column. So second row, 2 into 2 is 4, plus 1 into 1 is 1, plus 1 into 3 is 3. So that means 3 plus 1 plus 4. That is uh, 8, right? So 8, we obtained 8 here, right? Okay, so next column, what? The second row with the second column. So 2 into 4 is 8, 1 into 1 is 1, 1 into 0 is 0. So 8 plus 1, that is 9. Clear? So that's how we have obtained this, we perform this matrix multiplication. Now let's see the third element. The third row will be multiplied with the first column. Third row, 3 into 2 is 6, 1 into 1 is 1, 0 into 3 is 0. So that means 6 plus 1 is 7. Right? So next element, third row with the second column. 3 into 4 is 12, 1 into 1 is 1, 0 into 0 is 0. So 12 plus 1 is 13. Fourth row with the first column. So 0 into 2 is 0, 2 into 1 is 2, 2 into 3 is 6. 6 plus 2 is 8. We got it. Then fourth row with the second column. 0 into 4 is 0, 2 into 1 is 2, 2 into 0 is 0. So the resultant is 2. So that's how we have obtained this A multiplied by B or A cross B matrix, right? So the multiplication is done uh, the, by this formula, that you can obtain the element by multiplying the row with the column, the whole column, and add the corresponding numbers, right? So the product of two matrices is undefined when the number of columns in the first matrix is not the same as the number of rows in the second column, right? That's what we discussed just I mean few minutes ago. Okay, so now let's see the illustration. We already did it with one example, but just to let you know, if this is the matrix A11, A12 up to A1k, and then M into k matrix, then this matrix should be the k into n matrix, right? B11, B12 up to B1 and BKN. So you can multiply with the A11 with B11. That's how you are going to obtain this C11 element. So in order to obtain this C1 element, 11 element, you need to multiply this whole row. You need to multiply this whole row with this whole column and add them up, right? So you will get this C11. In order to obtain this C12, you need to multiply this whole first row with the second column, right? In order to obtain the C1n, you need to multiply this whole first row with the last nth column, right? And add them up and you will get this element. So that's how we have obtained this, and this is the formula. In order to multiply Cij, you need to get, I mean, you need to use this formula that I have explained in the previous slide as well. And you can simply code it in any programming language, C language, Java language, or whatever you want, in order to test your the results of this multiplication algorithm. Or you can do it in Microsoft Excel as well, right? So matrix multiplication is not commutative. That's quite obvious. So if you, for example, that means if you have this A matrix and this B matrix, does AB equal to BA? For sure not. So you can test it. For example, this is the result of the AB, and you can see, and you can pause the video and you can see how we have obtained this AB. And this is the result of this BA, and they both are not equal. Why they are not equal? You need to find the reason. Just stop the video here and get the answers of AB and BA and see why they are different, right? So in a nutshell, matrix multiplication is not commutative. That means AB is not equal to BA, right? Okay, what is an identity matrix? And what is the power of the matrices? So first of all, let's see what is an identity matrix. So the identity matrix of order n is the m cross n matrix, and we represent it with the in, right? That is equal to the delta ij. What does that delta ij mean? That is the diagonal element where delta ij equal to 1 if and only if I and j both are the same values. When I and j are the both values, that means the diagonal element. See, this is a11, this is a22, this is a33, a44, ann, right? So the identity matrix of order n is m cross n matrix in with delta ij, where delta ij is equal to 1 if I equal to j, and delta ij is equal to 0 if I and j both are not same. So if this is the value, this is the value, then we call it the identity matrix, right? Clear? So diagonal elements are 1, rest of the elements are 0, in short, right? So what do we mean by this a I n? If we multiply the identity matrix with a, so we always get, and if we multiply I with an other matrix, identity matrix im, we always get the same matrix, and that's quite obvious. You can see that, right? So the power of square matrices can be defined if we have a square matrix. Identity matrix are the square matrices, right? So if it is a square matrix, we can find the power, right? What do we mean by the power? For example, if A is a matrix of n cross n matrix, we can say A power 0 means A is the simple matrix, that is the identity matrix. A power r means, for example, if r is 5, so a is multiplied with itself 5 times. So a power r means r times, it is multiplied with itself r times, and that's quite obvious. That means the power of a matrix, right? Okay. Now, transpose of matrices. So what do we mean by the transposition or transpose of a matrix? So in a nutshell, let A is equal to Aij be an m cross n matrix. So the transpose of A, that is denoted by this A T, is the n cross m matrix, right? You can see the matrix was originally m cross n, but when we take the transpose, this becomes the n cross m. That means the rows, the columns will become rows, and the rows will become columns, obtained by interchanging the rows and the columns of A. So for example, the transpose of this matrix 1 2 3 4 5 6, this is a matrix. So the transposition is convert this row into column, that is 1 2 3. Now 1 2 3 will be at the column place, right? And 4 5 6, that is the row, that will again be the at the column place. That is called the transposition of the matrix. We interchange the rows with the columns. So mathematically, if AT transposition is equal to Bij, then Bij is equal to Aji, obviously. So you are going to interchange the column and rows with each other. For I is equal to 1, 2, or whatever is the number of the I, and j is any number, any positive integer, right? Okay. So a square metric A is called symmetric, right? What does it mean? Now this is the definition of the symmetric metric. What is a symmetric metric? If A is equal to a transpose of the metric, that means if you take the transpose of a metric and it remains the same, then we call this type of the metric, we call it a symmetric metric, right? So if you take the transpose, you interchange the number rows and columns, but still it have the same values, the same metrics, then we call it a symmetric metric. But this only applies to the square metric, obviously, right? For the transposition metric. Clear? So okay, square matrices do not change when their rows and columns are interchanged. That's what I said. When we if the column is the square metric, if you change the if it is a square metric, that will always be the symmetric matrix, right? 0 1 matrix, this is very much used in computer science. So a matrix all of whose entities are either 0 or 1 is called 0 1 matrix. So such matrix where all the entities are either zeros or ones, right? So algorithms operating on discrete structure represented by 0 1 matrices are based on Boolean arithmetic defined by the following Boolean operations. So that means we have the 0 1 matrices that are widely used in computer science and in the computation, but in order to and if we have the 0 1 matrices, we can easily apply all the arithmetics, the addition and the subtraction, but those arithmetic is also called the Boolean arithmetic. And we already know what is the Boolean arithmetic that we learned in the propositional logic. That is either we can use two operators, either and or, right? So we already know this B1 and B2. We know the value of the B1. This will only be true when B1 and B2 both are 1. Otherwise, it would be 0, right? So in other words, this is actually equivalent to the multiplication of the two numbers, but that is not always true. Just to give you the a hint for remembering it, right? So or means B1 or B2, that is somehow we call it the plus, but I will come in the next slide. The join and the meet, what does it mean actually? So this is true. This will be 1 when both, either one of B1 or B2 is 1, and it will be 0 if both are zeros, right? So that we learned in the Boolean logic as well. So let A is equal to Aij and B is equal to Bij be M cross and 0 1 matrices, right? So the join of A and B is the 0 1 matrix. The resultant of this join, the definition is the join. We have this operation. So join means is the 0 1 matrix of the ith and jth entry that we can obtain with the help of this operation, right? Or operation. So if we are performing the ORing, we call this operation join operation instead of the addition. So the join of A and B is denoted by A or B, right? But if we are doing the A and B, right, this is called meet, right? So the meet of A and B is the 0 1 matrix with I comma jth entry Aij and Bij. The meet of A and B is denoted by A cross A and B, right? Clear? Let's see the example. So find the join and meet of the 0 1 matrices. So for example, if this is the A matrix, say 0 1 matrix, B is also the 0 1 matrix. 0 1 means they have either 0 value or the 1 value in place. So the join, what is the join? If you remember, join is the ORing, right? If we perform the OR operation. So join is how we are going to do that. A join B means we will do the OR operation to the every corresponding element, right? So 1 or 0, 0 or 1, 1 or 0, 0 or 1, 1 or 1, 0 or 0. And we know that this is 1, this is 0, this is again 1, this is again 1. Any one of 1 is 1. 0 or 1 is 1, 1 or 1 is 1. This will be only 0 when both are the zeros, right? That's why this is called the join of two 0 1 matrices. And what if we do meet of the two 0 1 matrices, right? So meet is A and B. So here you can simply say that 1, okay, 1 and 0, right? You can see from the values here 1 and 0, right? So 1 and 0, 0 and 1, 1 and 0, okay, 0 and 1, 1 and 1, 0 and 0 from the matrix value corresponding values. So we know that this will be only 1 when both are 1. I mean, this value will be 1 only. All other are 0. 1 and 0 is 0, 0 and 1 is 0, 1 and 0 is 0, 0 and 1 is 0, 1 and 1 is 1 only, and then 0 and 0 is also 0. So this operation is called meet operation, and then ORing is called join operation, right? Now, Boolean product. So if that what I mean, in other words, this is called, I said that this is the plus operation, this is the multiplication operation, but that is just for the remembering. What about the multiplication or the product of 0 1 matrices? If we want to multiply two 0 1 matrices, so let A is equal to Aij be an M cross K 0 1 matrix, and B is equal to Bij be a K cross N. Remember, the number of columns of the first matrix should be equivalent to the number of rows of the second matrix. Then only you can get the product. that remains the same, the rule same remains the same, right? And the resultant will also be a 0 1 matrix. So the Boolean product of A and B, it is denoted by this circle, I mean a dot with a circle, is the M cross N 0 1 matrix with I comma jth entry. And how that entry is being done, similarly, I mean that as we have seen in the integer forms, AI1, the ith first element of the ith row ended with the that's why I said the multiplication ended with the first element of the jth column, right? Then we will take an OR it with the I2 and B2j and goes on up to this one. So let's see the example here, then we will understand it better. So if we want to take the Boolean product, like for example A B, right? What is that? So what I said, this element 1 will be ended with this value and 1, then we will take an OR with the next one, then what will happen, right? uh, okay, 0 will be ended with this 0, right? So the first row, first column, right? For the second element here, you got the idea. I have the solution in the next slide. You got the idea, right? So what will be the answer? 1 and 1 is 1, 0 and 0 is 0, so 1 or 0 is the answer would be 1. So the first element of A dot A cross product B would be 1 here, and then we need to find the rest of the element. So that is solved here. You can pause the video and you can see how it is solved. So at the end you will see 1 and 1 or 0 and 0, then the next element, then the next element. We have obtained these elements by the same following the same rules, and then this would be the resultant matrix of two, the product of the 201 matrix, right? Okay. Boolean powers, it's similar to the again to the power of the normal matrices that having the integer values. So let A be a square 0 1 matrix and R be a positive integer. Then Rth Boolean power of A is the Boolean product of factor of A denoted by AR. That means AR is multiplied R times. So R is 5. A is multiplied with A itself 5 times, right? We defined AR to be an IN, that is the identity matrix. So the Boolean product is well defined because the Boolean product of matrices is associative. So the Boolean product is well defined. It is an associative. It has I mean it is well defined and very well used in computer science. That we'll see the applications of the matrices in rest of the in variety of the courses in computer science, especially in machine learning and other related things, right? So the Boolean power, if A is equal to this matrix 1 0 0 1 1 0 0 is 1 1 0, so find an for positive integers n. So for example, if n is equal to 2, that means A into A, right? Two multiplication of two matrices. So you just need to multiply, like I mean to get the product, like we have got in the previous slides. So you will, when you will multiply, you will get this matrix. So if you are going to find the third power, then what does that mean? You already obtained A square, that is this one, multiply it with A again, and then you will get A power 3. And so similarly A power 4, you already obtained A power 3, so multiply it with A and you will get this value. And you need to you will move on doing this for all the positive integers, right? So that's we have the power of the Boolean 0 1 matrices. All right, so that was all about this lecture about the matrices, and then when we will use the matrices in later lectures, we will see more details. Until then, watch the video, prepare your questions, take care, and bye bye.